Hello everybody, it's Crazy Logics here on YouTube, Crazy Logics in the forum, and everybody else just calls me Damon. Couple of whole kinds of new firsts here. I'm using a different video camera, might be good, might be bad. We're trying it. I'm also using my headset to record to help maybe block out a little bit of the background noise, but we're going to adjust it down just a touch. But we're going to try it. It may be horrible. So the other new first is I have a Sundown audio amp. I've never got a chance to work on an actual Sundown amp. I've repaired lots of Korean style boards, a lot of them made in China, you know, because Chinese are knocking those off for a lot of different manufacturers, but never a Sundown. So the first thing I'm doing is I want to pull the top off this. So we got a whole lot of firsts going on here. And so Sundown, always more expensive. This should be a Korean style, I'm assuming. It's a SAE-1000D, but look at that. That is two things I wanted to do. One is get underneath here and clean all the accumulated dust out. But that is a solid chunk of aluminum that they've just put their logo on. And that's pretty cool, because most of the manufacturers just go with whatever the heatsink is, and then get their brand on it. I can point to a few amps on my channel that I've done that are the exact same thing. You slide the board out, one board's red, the other board's green, but they are the exact same thing. They're in the exact same heat sink with just different writing on the top. So Sundown's got their own nice little custom heat sink here, and they put a nice chunk of aluminum for that metal. I like that. It looks good. This amp's pretty good shape. Don't know what's wrong with this amp. Big shout out to my buddy Shane. I kind of sent out a message to several of the repair techs I know that says, hey, I'd like to get a hold of a Sundown or two and be able to do my own kind of comparison. I've not got a chance to see, are these suckers, you know, do they have the better thickness board? Are their copper traces better? Do they use the better components so that makes them worth the money? You know, obviously you can blow anything. You can't build an amp so stout that anybody could afford, really, that you can't blow. Anybody can tear up an amplifier. But so the other first thing that's coming up is I'm getting crazy close to 1,000 subscribers, and that's a really big milestone. And so as we start to tear this thing down, we'll talk about it. I'm gonna have to sneeze or something here. Oh, pardon me. It is Old Man Winter is in full effect. It's in single-digit temperatures here, and so I've got the heaters running. I'm bundled up. It's dusty out here, and so I'm full. Got the sniffle from dust and everything else, because I've stuffed sheets at the edges of the garage door where air was getting in and all kinds of stuff. It's just cold, but we're gonna persevere. So anyway, never opened this amp before. Had a clue what's wrong with it. Shane was nice enough to send me a few older Sundown amps. He works on a lot of amps, and he does a whole lot of newer Sundown stuff. He had some old stuff laying around, and he was like, man, I just don't have time to get to it. And so we made a deal, and Shazam, there she is, Sundown Audio. It's 1000. This is the version 1. So I can see some black and charring here. So it looks like power comes in. This is our input filtering caps. This looks like the power supply. Somewhere here is My old man spectacles, there they are. These are all labeled Q, so we got 2, 4, 6, 8, 10. 10 FETs, and it looks like we've blown part of the power supply. My guess, 5 FETs for each side of the big power supply transformer. Here is the rectifiers. This is the outputs. There's the main rails. This is the output filter, one of the output filter inductors, it looks like. There's another one. Output relay, some output filtering capacitors, and this is the preamp section. So one thing we didn't do, I didn't even think to do, I always look into all the terminals to see if there's a bunch of copper strands that somebody's left there. This is not, so that's good. And if so, I clean them out, and then I look down all the RCAs and stuff and see and make sure I don't have anything broke off in there. So awesome. Well, it's pretty obvious this one will not pass our power supply test that we can do with our multimeter in diode mode, which puts out about 3 volts. But you hook, if you have your probes correct in here on multimeter mode, and you use the red to the positive, black to the negative. We're going to do that. Around. And see, it's just beeping. Get in there real close. So anyway, obvious blown power supply, but we can kind of see that. We're going to leave that on diode test because we're going to go ahead and check a few things. So I've got a new camera. Don't know if it's going to be as good a picture. Definitely blown there. So, so we know that side. The other side, definitely blown. Something there. So let's check the outputs. Here's a little something I've learned about amps, especially after working on some midline JLs, some lower end JLs. I'll try to edit out those coughs. If I don't get them all out, I'll try to, if you notice it, go quiet real quick. Like I said, my going inside and outside makes smell. Your nose gets cold, it runs a little bit, get the runnage in the back of your throat a little bit, and I don't like it. So anyway, like I was saying, one thing I've noticed sometimes is if you don't have blown outputs, sometimes that tells you that somebody hooked this up backwards maybe, but sometimes the output section has been built with more current capability than to handle more current capability than the input section can supply, and that's why the power supply would blow, but the outputs would not. Of course, if your output side blows, if say it's a little weaker than the power supply, it can still, because it becomes dead short, blow a strong power supply. And normally manufacturers, make that roughly equal, but one of the two is always going to be slightly stronger. So there's a chance that this amp was just running at really low ohms, probably lower than recommended, and was hammering away and slowly got these FETs good and hot, and finally they popped. You never know. I don't know the history on this amp or nothing. So the board looks pretty good. Let's start taking it apart, and we will talk about the other big thing. So the camera first. Let's back up here a minute. So I got the capability to zoom. We're going to zoom here in a minute, but it may shake you terrible, and you may hate it. But look at there. We are going to have the ability to go down and show the board really well. Now you notice the camera's shaking a little bit right now as it's settling. It's on a very wobbly mount. I have got to come up with a good mount that is not touching my workbench, so that when I do this, the camera doesn't do wiggle. I've got it mounted up on a couple of 1x2s basically hanging out there, so it's not very done. So anything we zoom in on here may end up being shaky. It's progress. Stick with me. Progress. Doing the best I can with the resources I got and the resources I can get when I can afford them, without spending money unwisely, because I don't make any money doing this off YouTube or anything like that. And then even when I fix amps and sell them to somebody, I'm so far in the hole with some tools and supplies and stuff laying around that yeah, it's just ask anybody that likes to tinker with fixing anything, you get in the hole real quick. Hobbies are expensive. So that gets that out. There's some screws in the middle of the board and on the edges of the board, but we're going to have to pull one side at least. I'm going to be Allen wrenching here. We'll go ahead and talk about the one that coming up, maybe someday. Coming close to 1,000 subscribers. I think as of this video I'm at like 865, which is unfathomable to me. I didn't know there was 865 crazy people out there in the world that were willing to listen to some lunatic fix electronics, especially a goober. So to all you crazy people, thank you so much. I totally appreciate it. I started this channel to give back. I can fix stuff. I like fixing stuff, and so I fixed a lot of my own things, thanks to YouTubers posting up, this is where this device is on your car, this is how to take your back seat out because it's got a hidden latch that nobody can ever find, and here's what it is, what it looks like, and this is how to take your laptop apart without breaking all the plastic clips, and that allowed me to take my wife's laptop apart and put a new charging jack in it so that she could continue to use her laptop when the charging jack broke. So I'm very, very thankful. Wow, those guts are exploded big time right there. To all the people that upload videos, and I'm super thankful for all the people like Jessa Jones, Louis Rossman, tons, Andrew Paul, my mate Vince. There's just too many to go around that that share how they fix things and stuff like that, and I enjoy it. And then even the huge big channels like AVG, showing how he works on things. This old Tony, I've got a crazy subscription list of stuff. I just like working on things. I like having stuff. My dream is to have some kind of shop of my own out on a little bit of land so that I have enough room to put all my toys, which would be tools. I call them toys, but it is really satisfying to me to be able to fix something, to make something, to remake something, rebuild something, do it yourself, and so that's one of the things I love. So that's a big reason why I started the channel. The other thing was I got lucky and I had a couple good mentors in life, besides my parents and stuff like that, but I've had a few other good mentors, and I've been told by several people throughout my life that if you can explain how something works and how to fix it and all that other stuff to somebody else, then you truly understand it. And I found that to be true in life. And also I found that when I I'm not 100% perfect on something, when I go to try to explain it and go to do all that stuff, it gives me a better understanding. I figure out where my gaps in my knowledge are, you know, what I do and don't understand, and so that really, really helps me to learn myself. So by putting these videos out, I'm helping myself. I mean, a little bit selfish of me, but it is what it is. I get to get better at learning these things. Most rectifiers for amplifiers are either two diodes facing in or two diodes facing out, and so the outer legs should show short, and then they should show diode check to the middle leg, and that's what they're going to end up if I let it go. Some of them are two diodes facing one way, so you have to double check sometimes. You know, a few amps use that. So we definitely have blown power supply here. So get my old man specs, and oh, since I was able to get a new camera, howdy everybody, I can do a little bit of that because I was able to move one of my cameras. So this uses the 80N08s, so it's 80 80N08, and I know that I can put 3205s in that. 1B10, and then it's got, ooh, well that's peculiar. So it's got what is here as a B31N20. Some of them are FB31N20, and they've all got a D on the end. I'm going to put this with the cover. Just, man, I roll a painter's tape and a marker so that when you're pulling this out, oh, I need to write 26 on there, I believe. I'll look at that a little bit better. But as I'm sorting through amps, and there's the bottom cover, I'll just stick it on there. As I'm sorting through amps, and I'm initially figuring out if I need to order parts or whatever, I'll go through. So here's a pro tip: get a little bit of thermal paste on your finger for the ones that are hard to read, and rub it on there. These really didn't have much thermal paste. It was all this is a little bit of the an older Sundown, so its thermal paste is a little dry. But you can rub it on these and it'll get down into the grooves. So here's what I got. Let's get the pointer out. Let's do a little pointing here. 31N20s. Here, all of them. This batch is 113P. These three match. This one does not match anything, that one does not match anything, and that one does not match anything. My opinion after seeing this is that somebody has blown the output section before, it somehow survived good enough that they swapped in some bad fets, or well, not bad fets, but mismatched fets. Because there's no, well, it's pretty good solder joints. They still look a little, yeah, even this one. There might have been one of this batch. I think this was the original batch over here that survived, and I think they swapped it in over there, because that one looks like it's been soldered. And these others have been changed. So, even though they may test good, I'm going to have to replace all these, because I don't play that game. Everything needs to be matching. And the reason why everything needs to be matching, if you see these are all three different, let's say, I don't know yet here, let's say this is the high side and that's the low side. When the high side's running, the different batches, the slight variation in them, means one of these is going to have lower resistance than the other two. One of them's going to have the highest resistance out of these three. And so the lowest resistance one's going to end up doing more work, and the highest resistance one's going to do less work, and it's just going to keep loading up that one FET more and more and more, and it's going to start making higher, more and more heat until it fails first. And that's why you use matched batches. That way they're all from the same production batch. They should all be so super close, and that way they evenly spread the workload in parallel groups. So in this one, let me show you on the power supply side here. The way to determine this, and I've showed it in some videos, is on your gate leg here. We're still in multimeter mode here. On your gate leg, you should be able to go and find the side of the resistor that's hooked to the gate leg. Go to the other side of that resistor, and then touch all the other resistors on that same side. It's going to be a little bit hard because some of these are shorted. But there, 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 there. It does not seem like it should be. But remember, we've got shorted FETs. You actually need to do this with the FETs out, because it should show this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You know, because this is a push-pull setup for the transformer on the power supply. So when we pull these FETs, I'll redo that test and let you see that. But you'll be able to check on the driver side that they're all in parallel, and you can actually see where the there we go. That's doing a better job. I was on the wrong side. It's because everything's shorted and some of these are fried. So these need to get cleaned up. But you can see sometimes the traces on the board. Oh, hey, we got a cool new camera, guys. Let's zoom in. Oh yeah, here we go. I can explain this and actually show you. Okay, so this dark part of the board has no copper. Copper is these traces here. Then they cover it on this board. They covered it in a red conformal coating. So you can see this little trace, and it goes to this resistor, and this resistor, and this resistor, and as we move down, it continues going on. And it's running behind all these FETs. It goes down to here, and then if you look over here, this resistor for this leg of the FET, it's on this line right here, and it's got a little bitty trace. If you look real close, I wonder if I can zoom in even more. Or shake and wobble here, I'm sorry. Well, let focus. No, Okay, so we've about hit our max. Let's back up just a touch. Come on, focus, stop shaking. I think I'm so shaky that I'm going to keep it shaking. Alright, sorry about the little bit of shake. Like I said, we'll get a better setup. But if you look where this trace hooks here, right here underneath this R58, which is the number for this resistor, that trace runs back here to this little driver transistor. This one runs back here to this little driver transistor. Now these two diodes are clamping diodes for these transistor setups. And so based on that, oh yeah, we've had some other work. Look at this. There is the, let's see if I can get a little thermal paste maybe. On the left. I'm going to get that to show up a little better. Yeah. There is the TL494. That's the pulse width modulation chip. Look, somebody's done a repair here. So that does, you know, okay, they got it in whatever it was supposed to be. I'll check on it. But if you've been watching my PPI video series, you notice I talked about the NPN and the PNP drivers and how they're connected. Well, this one is only using what appears to be only using the PNPs, and then it's using diodes instead of the NPNs for the pull, for the come up. So I'll see if in the second video I can't also draw this little circuit out that drives this power supply. And so excellent. This is going to be so much fun. Hopefully I can eventually get better cameras and a little better capture card. I just got super cheapo right now to get this working. But off camera, I'm going to pull all of the transistors, sorry, not transistors, FETs from the power supply, all of them from the output, since these are mixed match pair, and then I don't trust these three anymore. So we're going to get 6 new ones for here. We're going to get 10 new 3205s to put in here. I will also clean the board, and then I will probably double check all these gate resistors, and they are, let me get my little zoomy here so that we can probably look down at them under the thing. They're already 47 ohm. If they are not in perfect shape, 47 ohm works with the 3205 perfectly. So I'll go ahead and get that in there, and I'll check these little diodes and stuff, and then that's just going to be all multimeter checking. Once these are out, cleaned up, I can already see. Let's do that zoom again. We really should have pointed it out whenever we were looking at that section. There it is. Oh, that's as close as I can get it. Sorry, it's going to wobble. See this on this side, that side going to my left, your left, there is the side that really blew up, and that's the driver transistor, and you see that right there is a hole blown in the middle of it. So that one looks okay, but it may be okay, I don't know, but we'll definitely be checking those pieces, and we'll have to replace that. And I'll try to draw that out and try to explain it a little better. We can get a little over here. Puppy dogs are around behind me. But pull all those, clean this up, pull all these in the next video. And before I go, while I'm getting prepped here, looking at some of this stuff, I want to look at the circuit board. It feels good. You know, this is a Sundown. You pay more for these. You know, there's a nice bump. So the copper feels pretty good and thick. This has been worked on before. So the fact that it's in for a second repair and yet it does not look, we'll know for certain once I pull all these, does not look like it's all too awfully bad beat up. The mono piece here is wobbly and looks like it's broke. For the, I think that's for the, oh, here, it's right here is wobbly and broke. We'll figure that out, but that looks like it may have been soldered at one time, so this may have been strapped, maybe. Used in a strap setup. I think that's what that connector's for, and so we'll fix that. A whole bunch of stuff to look over. Excuse me. But back to the 1,000, getting close to 1,000 subscribers. That, that's thanks to everybody, and if you subscribe, like, comment, do all that stuff, I truly appreciate it. I'm a little bit scared to death about hitting 1,000 subscribers, because that's kind of a big milestone, and most everybody does something special for right after they hit the 1,000 subscriber. I don't have a clue what to do. I got a couple ideas, but I don't know really what's viable. I do know the old school SPL challenge is coming up, and I'm trying to pull together some stuff to be able to do that, but it's flipping freezing outside, so I don't want to go out and work in my truck or go try to do anything special for that right now. Besides, I'm trying to fix a few amps that I'm not recording to have them. My goal for the old school SPL challenge is to try to enter each class. I'm going to lose terribly, but that'll let kind of everybody see the difference maybe between a certain set of amps that I plan on using and some stuff like that. So anyway, leave some comments, maybe some ideas of what I should do for 1,000 subscriber special when it comes up, and then get all your buddies and friends, your mom and your dad, your grandma, and your neighbor, and your dentist, and your vet, and your mailman to subscribe, and let's get there, man. 1,000 subscribers. Let's make crazy logic so here uncomfortable and have to do something silly for 1,000 subscriber special thing. So like I said, I can't believe I've got so many already, and I'm truly appreciate it. So I'll do this work off camera, and then hopefully when you see it next, we'll be talking about some of them circuits and fixing up the power supply side, get it running. We'll test the output drive and everything, and then we'll see about doing that. I'm not sure if I have replacement FETs here, so we may have to do a little magic of YouTube. But this video's gone on long enough, and it's not a whole lot of repair, just a whole lot of talking and a little bit of showing. And but I do appreciate everybody, and stay warm. It is really cold here. Hopefully it's a little better where you're at. And, thanks for watching.